Hello everyone, today we're going to talk about Alzheimer's disease. So, contrary to popular belief, dementia is not technically a disease. It is rather a general term used to describe symptoms such as memory loss and other cognitive impairments. It is caused by diseases such as Alzheimer's disease, which is the leading cause of dementia, as it causes approximately 60 to 70% of all dementia cases. Alzheimer's is a neurodegenerative disease, which means that it leads to the loss of neurons. Symptoms also worsen with the progression of the disease, and it reaches a point where it severely interferes with daily tasks such as walking and eating. Alzheimer's disease is not fully understood, but scientists believe that age is the number one risk factor, with most cases being seen in people over the age of 65. The causes of Alzheimer's. So it is important to note that the causes are not fully understood, but two major players that are often cited are beta amyloid plaques and neurofibrillary tangles. Neurofibrillary tangles are less specific to Alzheimer's and are seen in many other dementia diseases, while beta amyloid plaques are the hallmark of Alzheimer's disease. Let's start by talking about beta amyloid. So everything starts with this receptor-like protein found in the cell membrane called the amyloid precursor protein, APP. It's actually one of the most studied proteins in science, but its function still remains unknown. A bunch of enzymes called secretases team up to slice the amyloid precursor protein to create these amyloid beta monomers. So these monomers are very sticky and aggregate to form plaques outside the cells and affect cell to cell communication. So these plaques were initially believed to be what causes Alzheimer's, but recent studies suggest that these plaques are simply a hallmark of the disease. But a more toxic form of beta amyloid aggregation are the insoluble oligomers. This is an example of how amyloid plaques look on histology, and recall that this occurs outside the neurons in the extracellular matrix. Now let's talk about neurofibrillary tangles. So recall that microtubules are a structural component that can act kind of as a railroad system and ship molecules and nutrients across the cell. Tau is a soluble protein that plays a crucial role in stabilizing these microtubules. In Alzheimer's, tau is hyperphosphorylated by kinases, which are enzymes that add phosphate groups to molecules. When it is hyperphosphorylated, it aggregates to form those tangles, which fails to stabilize the microtubules. This affects the cell communication and signaling. Similarly to beta amyloid, those tau tangles are not the most toxic form. Instead, the tau protein also forms oligomers, which are believed to be more toxic than the tangles. This is an example of how those tau tangles look on histology, and recall that these occur inside the neurons. To understand the genetics and heredity of Alzheimer's disease, we must consider the two types of Alzheimer's, which are sporadic Alzheimer's and familial Alzheimer's. Sporadic Alzheimer's, also known as late onset Alzheimer's, is the most common type of the disease and is seen in approximately 95% of all cases. Many genes have been identified, but the major one is the apolipoprotein E, or APOE gene. This gene codes for a protein that mainly transports cholesterol, but also plays a role in degrading beta amyloid. There are three known alleles for the APOE gene: the E2, E3, and E4 allele. The E2 allele is essentially the most effective at degrading beta amyloid, and individuals who have one or two of the E2 alleles are at a decreased risk of developing the disease. The E4 allele is the least effective at breaking down beta amyloid, and having one of these alleles increases the risk of developing Alzheimer's, and having two increases the risk even more, and it is approximated that it increases the risk up to 12 times. It is important to understand that having one or two copies of the E4 allele does not mean a predisposition to Alzheimer's. Many people who have the allele never develop Alzheimer's, and many people who did not have the allele develop it. Familial Alzheimer's, also known as early onset Alzheimer's, is a lot less common and accounts for only 5% of the cases, and it is characterized by an earlier age of onset, this being before the age of 65, and a more aggressive course of the disease. So, several mutations can cause familial Alzheimer's, and they are usually inherited in an autosomal dominant pattern. For example, the APP gene codes for the amyloid precursor protein, and mutations in this gene can lead to an increased level of APP and therefore more beta amyloid aggregation, whether it's in form of plaques or oligomers like we discussed before. The PSEN1 and PSEN2 genes encode for enzymes that are part of the secretase complex that splices the APP, and mutation in those genes can lead to a secretase that splices a longer part of the APP, which is also better at aggregating. The current state of Alzheimer's. So there's currently no cure for Alzheimer's, but many drugs that help with memory loss and other behavioral issues are often prescribed. So these drugs are also prescribed to people with mental health issues and depression. There are also drugs that directly target beta amyloid, but these are dangerous and the risk to reward is often not worth it. Non pharmacological interventions are also very important, and adapting to the needs of patients with Alzheimer's, such as creating routine habits and cutting down tasks that require memory, can facilitate their lives. Finally, although diagnosis is very hard, early diagnosis is key and has many benefits, including better use of the medications and better patient life satisfaction. Alzheimer's disease raises a lot of bioethical questions and concerns, and I'm going to give you an example of a question that is open ended. So, how should patient autonomy be approached as the patient's condition worsens? Should loved ones make decisions even if it means being less than fully transparent? So, these type of questions don't always have a clear answer, but asking them is the first step toward making care more compassionate, fair, and human. Thank you so much for listening, and I hope you enjoyed this video.